Hello, today we are talking about 2.6.2 Introduction to Proofs. The essential question, how can I write a proof? To be able to do that, we first need to know what a proof is. So some definitions. A proof is a step-by-step description of how you came to an answer, which includes justifications or reasons. That's what a proof is. A two-column proof is a type of proof, and that's the type of proof we're going to be doing today. We will do these. They're the same thing as a proof, it's just a specific kind. So a two-column proof is a proof that lists the steps you took to get to an answer on one side and lists the justifications or reasons on the other side. So in order to prove something is true, you have to both explain what you did to find your answer and give a reason for why what you did works, why what you did is valid. So first off, in order to do a proof, we need to have a question to prove. So let's find x. This isn't a proof. We're just going to find what x is equal to. And then after we find what x is equal to, we'll actually prove it. This is one we did on a previous video, yesterday's video, I believe. So it shouldn't be too hard. Let's see if we can figure out what x is. All right. First thing I'm going to do is look at this 110. I'm like, okay, well, these two angles together form a linear pair, right? Linear pair, they form a line, which means they add to 180. So if this one's 110, that angle 1, that must be 70 degrees. But if angle 1 is 70 degrees, then I know angle 2 is also 70 degrees because they have these tick marks, right? Tick mark there, and I know tick marks make them equal. And if angle 2 is 70, then angle x is also 70. Not because there's any tick marks there, but because we've got some vertical angles. Again, vertical angles are angles that are across from each other when two lines intersect. All right, so we found angle x. We found x is equal to 70 degrees, which is true. But just saying that it's equal to 70 is not a proof. I could have easily said, oh, x equals 22 degrees, right? That's a claim. I'm claiming it's 70 degrees. To prove it, I'm going to have to describe all the steps we took to get here and then say why each step was okay. So we're going to do this one more time, but this time we're going to prove it. So now the problem is to prove that x is equal to 70 degrees. I went ahead and showed each step I did in the previous proof right here. So those are already written out for you. When you do your homework, those will tend to be already written out from you because we're just introducing proofs. So I don't want to break it all down. But what I do want to work on is see if we can come up for reasons for why each of those things is true. So our very first statement was that I knew angle 1 plus 110 equals 180. I knew these angles together. When I added them together, I knew it was 180. But I got to give a reason for why I know that's true. So how do I know those two angles add up to 180? Well, because they're a linear pair. They form a line. So that's going to be the reason. So in a proof, you state what you know, and then you give a reason for why you know it's true. All right. The reason I know that is true is because linear pairs sum to 180 degrees. All right. Next, I said angle 1 is 70 degrees. Well, I got that straight from here, right? If angle 1 plus 110 is 180, that angle 1 is going to have to be 70 degrees, right? How you describe that is really up to you. Like, there's no one right way to answer it. I could say subtract 110 from both sides, right? I mean, that's literally how I would have done it with algebra. I would have said minus 110 degrees, minus 110 degrees. Those cancel out. Hey, that angle 1 is 70, right? That's how we do it with algebra. If you wanted to be fancy, there's an algebraic property that allows us to subtract 110 from both sides. It's called the subtraction property of equality. I'm not worried that you write the subtraction property of equality. It sounds cool. It's all mathy. It's awesome. But all I really want is some reason that you can go from here to there. You could say I subtracted 110 from both sides. You could say if angle 1 plus 110 is 180, then angle 1 has to be 70. Some kind of reason to say that that's okay. All right. The next statement I said was that angle 2 was equal to 1. So again, that was when I was working through this picture. Like after I found that this one was 70, I said that angle 2 and angle 1 were the same. Well, how do I know they're the same? Well, again, because of those tick marks, right? So if you wanted to write tick marks, That's actually just fine. You can write because of those tick marks I saw. Again, there's a fancy one. You could just say the word given. Given just means it was something that was given to be true in the picture. They gave it that angle 1 and angle 2 is true because they gave it to you because of those tick marks. So you can write tick marks or you can write given. They both mean the same thing. They just mean that there's some reason indicating that you knew angle 1 is equal to angle 2. All right. The next statement, I said angle 2 is equal to 70. I said, hey, I know this is 70. How did I know that? Well, I knew it because angle 1 was 70, right? Angle 1 was 70. There's angle 1. I can just change it to a 70. I literally said, since I know angle 1 is 70, I can change that angle 1 into a 70. There's a fancy name for that. It's called substitution. And we'll go over these fancy names, but it's not too important. Just somehow indicating like, oh, I get it. I knew angle 1 was 70 degrees, so I wrote 70 in place of angle 1. If you wanted to write all that, you could. All right. Next, I said that I happen to know angle x was equal to angle 2. So x was equal to angle 2. So again, let's look over here. Why did I know those two were equal? Oh, that because they were vertical angles. So let's write them. Vertical angles. In fact, more specific, I know vertical angles are congruent, right? I know vertical angles are congruent, so I can write that. That's how I knew angle 2 and x were equal. And then very last one, I said, well, that means x is 70. How did we know that? Again, because I knew angle 2 was 70. I said it right here, right? So that would be that fancy substitution again. It's basically write the statement on one side, write the reasons for your statement on the other side. There are a couple of justifications we talked about in that proof that might be helpful for you. There's a subtraction property of equality, which just states that when you subtract the same number from two sides of an equation, it results in another thing that's equal. That we had that example right here when we went from angle 1 plus 110 equals 180 to angle 1 equals 70. We got that because we subtracted 110 from both sides. Right? That got us to this part. That's the subtraction property of equality. Again, you don't need that, but it's pretty handy to have. You don't have to just write down, I subtracted 110 from each side. This given is a super important one. Anytime you are given something to be true, you don't have to say, hey, it's true because of tick marks or because it says so in the problem. You can just say the word given. And substitution, that's a pretty big one too. Anytime you know the value of one thing and you're substituting it in, that's substitution. So if you have some equation, say angle 1 plus angle 3 equals angle 4, and you happen to know angle 1 is 50 degrees, and you happen to know angle 3 is 30 degrees, and you replace those like that, that's called substitution. I'm substituting the 50 degrees in for angle 1. I'm substituting the 30 degrees in for angle 3. All right, let's try one more, and then we'll end this video. This one, again, this is a problem we did as a class, but let's figure out x, and then we'll see if we can list out the steps we took to figure it out and actually prove it. First, it tells me angle lan and angle can are complementary. I know complementary means adds up to 90 degrees. Here's lan right there. Here's can right there. So those two angles add up to 90, which means that must be 15, because 15 plus 75, that's 90. Oh, and then it says I really want to find x, but now I got it. X right there. Notice how it's across from this angle, right? And two lines intersect. Those are vertical angles. So I know x must be 15. All right. Let's actually go about the proof of it then. So here are some statements. Let's see if we can figure out reasons for why I can make each one of these statements. First one is angle lan and angle can are complementary. Why do I know that? Because the problem told me so. I could write the problem told me so, but the easier word for that is just given. That was something that was given to be true. All right, then I said angle lan and angle can equals 90 degrees. How did I know that? How did I know these two together were 90? Because they were complementary. Like that's what it means to be complementary. So you could just write definition of a complementary, or you could write complementary angles at sum to 90, whatever you want. I like that one. I'm gonna write complementary angles sum to 90 degrees. That's why I was able to write that. All right, well, if those equal 90, oh, wait, let's see what's different between those two things. First, I wrote angle LAN plus angle CAN equals 90. Now I wrote angle LAN plus 75 degrees equals 90. I changed this angle CAN to 75 because here it is. That's what angle CAN was. Fancy name for that, substitution. I substituted that 75 in for the angle CAN because I knew angle CAN was 75. All right. Then I went to this part and suddenly said angle LAN was 15. How did I know that? Oh yeah, that's right. If I subtract 75 from this side, subtract 75 from that side, these go away. I get LAN by itself. 90 minus 75, that's 15. That's when I subtracted the same number from both sides. The fancy one for that, if you want to use a fancy one, would be the subtraction property of equality. All right. Then I said angle X. I said X is equal to LAN. How did I know that again? Here's angle LAN. Here's X. Oh yeah, that's right. Those are vertical angles. Vertical angles are congruent. Vertical angles are, and I'm going to use just the congruent symbol here so I can fit it in there. And last, I changed that LAN to 15 degrees because I knew it was equal to 15, right? So since I changed it to 15, that's just, again, substitution. All right, that's what proofs look like. You list what you know on one side, these are the things I knew, and how you knew it on the other side. These reasons, the how you knew it, again, I use some fancy words like substitution and the subtraction property of equality. Those are really, really handy to use. I would recommend you use them. But I'm like, it doesn't have to be word for word, right? It just needs to be something that explains why I could make that statement. Your homework today is going to look very much like this, except some things will be missing. Like maybe this one's missing and that one's missing. And you're going to have to figure out why it is. You're going to have to kind of work through and be like, all right, wait, how did he know this? How do we know that's true? And you can look at it and hopefully you can see, oh yeah, that was given, right? And then you can't just figure this out without looking at the top, right? If I take all this top away and you just say that, you're not going to have a reason. So you're going to have to like walk through the proof and see if you can figure out each of these. Like don't just skip to the bottom and be like, I got to figure out that bottom thing, because that might not make any sense unless you walk through the rest of the proof and figure out where it's coming from. All right. Today's a worksheet. It's called Introduction to Proofs. When you download that worksheet, see the last page of the worksheet for some hints. I know proofs are new. It can be kind of weird, but definitely just kind of walk through the proof and see if you can understand each step, even the ones that are written in. That, like being able to understand, that's going to totally help you get to the end. Just because the bottom one's blank, if you don't read all the other stuff above it, right? Like if you were asked to fill in that blank, if you don't read all of this stuff that was above it, that blank is going to be really hard to fill in. So, right? So read this through the proof a step at a time until you get to that blank. And then hopefully like, oh, I get why they said it's 15. Because right above it, they said it was equal to X is equal to LAN. And here, I already knew LAN was equal to 15 degrees. That's why I could do it. I use that substitution thing. All right. Worksheet. Last page of the worksheet has hints. Good luck.